Okay, so let's move on to question number 7. What is the volume of 5.6 grams of oxygen at 7.78 atm and 415 Kelvin? Please show all work? Question mark. Okay, so first I'm going to write down everything that we know. We know the mass of oxygen, and it is 5.60 grams. I'm actually also going to write the molar mass of oxygen, which is 16 grams per mole. And it's always good practice to just calculate the number of moles from there so that everything is in order. So to calculate number of moles, it's going to be the mass over the molar mass. So plugging those values in, 5.6 divided by 16 grams per mole. Our grams cancel out, and mass of O2 is not 16, it's 32, because there are 2 oxygens. Always double check your work. And you should end up with 0.175 moles of O2. What's also given is the pressure. So we know pressure is equal to 7.78 atm. And we're also given the temperature in Kelvin already, so you don't have to convert anything. And then the equation that we want to use is PV equals nRT. So this is a very commonly used equation. It's for ideal gases. Doesn't say in the question, but we are going to assume that it is an ideal gas, and it's just like oxygen. So we are looking for volume, and we have pressure, temperature, number of moles now, and for R, it is just the constant. So there's a lot of different R constants, so just be aware and make sure you use the right one. So for this particular question, I'm using 0.08205, and that's because it's in the units that I'm looking for. So I know I have liters times ATM. I also have a mole and K. So that is why I have chosen that value for the R constant. Okay, so if we rearrange the PV equals nRT equation, we can solve for volume, which is just going to be nRT over pressure. And then I'm just going to plug in what we have. So 0.175 moles. This is going to be multiplied by this gas constant, which is in liters times atmosphere times mole per K. And then temperature is just 415 Kelvin. All of that is going to be divided by pressure, which is 7.78 atm. Okay, so now you'll notice all the units should nicely cancel out. So that's how you know that you have the right R constant, if all the units cancel out nicely. So this will give us a final volume of 0.769 liters. Let's look at the answer from our junior tutor. We will use the classic equation PV equals nRT. P is pressure, V is volume, N is moles, R is gas constant, T is temp and K. Plug in what you know, so then they also found the number of moles, and they got 0.769 liters. This solution is correct. And then I'll just put like a disclaimer, assuming O2 acts as an ideal gas. Okay, so moving on.